Consider the following systems: System I, System 2, where CS is the output and RS is the input of these systems. A System I has larger bandwidth and faster speed of response than System 2. B System 2 has larger bandwidth and faster speed of response than System I. C System I has larger bandwidth but System 2 has faster speed of response. D System 2 has larger bandwidth but System I has faster speed of response. The correct answer is System I has larger bandwidth and faster speed of response than System 2. Nyquist stability criterion is based on a theorem from the theory of complex variables. A true. B false. C. D. The correct answer is true. For the function GSHS, the phase crossover frequency is A 0.5 radsec, B 0.707 radsec, C 1.732 radsec, D 2 radsec. The correct answer is 0.707 radsec. While forming Routh's array, the situation of a row of zeros indicates that the system A has symmetrically located roots, B is not sensitive to variations in gain, C is stable, D is unstable. The correct answer is has symmetrically located roots. The frequency at which phase angle is 180 is called A phase crossover frequency, B stability limit frequency, C frequency of limited stability, D gain margin frequency. The correct answer is phase crossover frequency. In a mechanical accelerometer, the steady state displacement is a measure of A constant input acceleration, B constant input velocity, C either A or B, D neither A nor B. The correct answer is constant input acceleration. A unity feedback system has if input RT1 to TT3, the steady error is A 0, B 0.4, C 4, D infinity. The correct answer is infinity. In log magnitude board diagram, the slope of high frequency asymptote of 1 Gt is A 20 dB per decade, B 10 dB per decade, C 20 dB per octave, D 10 dB per octave. The correct answer is 20 dB per decade. A compensator has its pole and zero as shown in the given figure. A lag compensator, B lead compensator, C lead lag compensator, D series compensator. The correct answer is lead compensator. For a stable system having two or more gain crossover frequencies, the phase margin is measured A at lowest gain crossover frequency, B at highest gain crossover frequency, C at the gain crossover frequencies, D none of the above. The correct answer is at highest gain crossover frequency. In a second-order system, peak overshoot is independent of A damping factor, B natural frequency, C both damping factor and natural frequency, D neither damping factor nor natural frequency. The correct answer is natural frequency. Nyquist plot provides information about absolute stability as well as relative stability. A true, B false, C, D. The correct answer is true. Power handling capacity of wire-wound potentiometer used in control systems is about A 0.1 watts, B 5 watts, C 25 watts, D 100 watts. The correct answer is 5 watts. For a factor, the log A is a straight line with slope 20 dB decade, B is a straight line with slope 0 dB decade, C is a straight line with slope 20 dB decade, D is a straight line with slope 40 dB decade. The correct answer is a straight line with slope 40 dB decade. The number of stator field windings in an AC tachometer are A1, B2, C3, D4. The correct answer is 2. In using Nyquist stability criterion, it is not necessary to determine closed loop poles. A true, B false, C, D. The correct answer is true. The polar plot of transport lag is a unit circle. A true, B false, C, D. The correct answer is true. The given figure shows a hybrid servo-Z-stem. The components 1, 2, 3, 4 are respectively A. Amplifier demodulator DC servomotor and load. B. Demodulator amplifier DC servomotor and load. C. Demodulator DC servomotor amplifier and load. D. Amplifier DC servomotor demodulator and load. The correct answer is amplifier demodulator DC servomotor and load. For the signal flow graph of the given figure, consider the following statements. A123, B12, C23, D13. The correct answer is 13. For the transport lag GJEJT, the polar plot is A semicircle, B a circle, C a unit circle, D none of the above. The correct answer is a unit circle. Consider the following statements. A. Only one is correct. B. Both 1 and 2 are correct. C. Only 2 is correct. D. Both are wrong. The correct answer is both 1 and 2 are correct. For the factor, the corner frequency is A 0.5 radsec, B 1 radsec, C 2 radsec, D 4 radsec. The correct answer is 0.5 radsec. For a second-order system, the position of poles is shown in the given figure. This system is A. undamped, B. overdamped, C. underdamped, D. critically damped. The correct answer is underdamped. A lag compensator provides attenuation in A. very low frequency range, B. low frequency range, C. high frequency range, D. none of the above. The correct answer is high frequency range. A stepper motor is essentially A. synchronous motor, B. induction motor, C. DC motor, D. either B or C. The correct answer is a synchronous motor. The root locus branches A. start from open loop poles and terminate at zeros. B. start from open loop zeros and terminate at poles. C. may start from pole or zero and terminate at another pole or zero. D. none of the above. The correct answer is start from open loop poles and terminate at zeros. In force voltage analogy, displacement is analogous to A. current, B. voltage, C. charge, D. none of the above. The correct answer is charge. M circles are symmetrical with respect to real axis. A. true, B. false, C, D. The correct answer is true. For the system with the maximum resonance peak is A. 4, B. 4, 3, C. 2, D. 2, 3. The correct answer is 2, 3. The angular location of poles depends on A. undamped natural frequency, B. damping ratio, C. both A and B, D. neither A nor B. The correct answer is damping ratio. For the characteristic equation S5, S42, S32, S23, S15, 0, the number of roots in left half S-plane are A1, B2, C3, D5. The correct answer is 3. At corner frequency the phase angle of factor 11 jt is A 90, B 90, C 45, D 45. The correct answer is 45. Frequency response approach is a simple approach to control system design. A true, B false, C, D. The correct answer is true. The pole zero plot of the given figure is for A non-minimum phase function, B minimum phase function, C all pass function, D none of the above. The correct answer is minimum phase function. For stable network the real parts of poles and zeros of driving point functions must be A negative, B negative or 0, C 0, D positive. The correct answer is negative or 0. A compensating network has, if it is a phase lag circuit, the value of A should be A 0, B between 0 and 1, C 1, D more than 1. The correct answer is between 0 and 1. Consider the following expressions which indicate the step or impulse response of an initially relaxed system. A1 and 3, B1 and 4, C2 and 4, D2 and 3. The correct answer is 1 and 3. If Z is the number of zeros of one GSHS in the right half S plane, N is the number of clockwise encircle elements of one jaw point, P is the number of poles of GSHS in right half S plane, the Nyquist stability criterion can be expressed as AZNP, BZPN, CZNP, DZPN. The correct answer is ZNP. The given figure shows a control system. The maximum value of gain for which the system is stable is A3, B3, C4, D5. The correct answer is 3. In a synchro transmitter, A input is angular position of rotor shaft and output is stator voltages. B input is stator voltages and output is angular position of shaft. Input is rotor voltage and output is angular position of rotor shaft. C input is rotor voltage and output is angular position of rotor shaft. D input is angular position of rotor shaft and output is rotor voltage. The correct answer is input is angular position of rotor shaft and output is stator voltages. The polar plot of GJ1J is A positive imaginary axis, B positive real axis, C negative imaginary axis, D negative real axis. The correct answer is negative imaginary axis. The log magnitude for the system in the given figure is where TRC, A 20 log 1T, B 20 log 1T, C 10 log 12 T2, D 20 log 12 T2. The correct answer is 10 log 12 T2. For an unstable system, the gain margin is indicative of how much the gain should be decreased to make the system stable. A true, B false, C, D. The correct answer is true. In the signal flow graph of the given figure, the number of forward paths is A1, B2, C3, D4. The correct answer is 2.